In this video I will tell you how I prepare and test the medium, high and high frequency speakers. Actually they are full range speakers, but I will not use them as full range. I will use them in the enclosure with the big 15-inch Visaton speaker. So first thing that I had to do was find the polarity for these speakers, because all of them have to be in phase. If some of them are not in phase, the sound will not be very good and will be distorted. To check the polarity, on some speakers it is written down or painted. On these old Romanian speakers it was not painted. Maybe here something, a little bit of green paint, but I can't work with that, I'm not sure. So, to test the polarity, a simple battery, an accumulator in my case, red wire positive, black wire negative, and when attached to the speaker, if the positive, now I already have it marked, so I will put it directly here. I know where it is, but first I did not know that the membrane must go up. If the polarity is wrong, the membrane will go down. Let me show you. You see, it's going down. So we now know that plus is on this end, positive, and negative on this end. So positive written down, and on the negative side, it's not a rule, but I like to do it this way. I have the filter caps. They are 25 volts. It's a little bit low. This value, 25 volts, it should be 50 volts, but I did not find on my old electronics boards with 50 volts and 47 microfarads. So I use ones with 25 volts. I hope it will be okay. Anyway, I don't plan on using this system at very high volume, so probably they will last for a lot of years. If I at any moment hear something wrong from them, I will know what to check and what to replace, but I don't think it will be the case. I choose this value because the Visaton speaker is able to go to 4000 Hz, and these speakers, I don't know, I think you can see, I found a chart table actually online for 8 ohms, 4 ohms, 2 ohms speakers, and the frequency from which the speaker will start to produce sound using these values for capacitors. Okay, I can pronounce that really well. So I put two of them like this, positive to positive, in series. So I make a non-polarized capacitor, because polarized ones are not really good for sound, and I don't have any non-polarized ones. So I made my own, positive to positive, but this, if they are same value, reduces the value in half. In my case, so they are 47 microfarads. Now we have somewhere about 23.5, yes, 23.5, and this being a 4 ohm speaker, we look somewhere around here. So that means that somewhere around 1200 and 2000 Hertz, this speaker will start to produce sound. We look on the 4 ohms column. So this is about what I need and what I want. For the other speaker, it has the same shape, but it is a 8 ohm speaker. They did not have the values on them anymore, but I checked them with a multimeter, and it's close enough to 8 ohm, so I can assume that it is an 8 ohm speaker. But now the values have changed for these capacitors, because we are looking on another column. We are actually looking on the 8 ohms column, so I needed to, in this case I found 50 volts capacitors, and I needed two 22 microfarads ones. So this gives me 11 microfarads. Then that puts it again somewhere between the 1200 and 2000 Hertz. So these two will be almost the same in frequency and will work together very well. The third speaker is not Romanian made, it's very old also. It has a lighter membrane and it seems to produce higher pitch sounds. So in this case I used it with two, let me check, 50 volts 10 microfarads capacitors, again in series to produce non-polarized capacitor, and this gives me about 5 microfarads. Okay, it's an 8 ohm speaker, measured again, and this speaker will start to produce sound at about 4000 Hertz. We will test them a little bit at the end. Of course, for all of these speakers I searched positive and negative. So let me test this one so you can see it. It also moves up if I put the wires on it. I don't know if this is focused. You can see it move. Okay. Of course, these are not new capacitors, but I've tested all of them with my capacitance meter, and they all seem to have better values than most of the new ones that I can buy around here, which are no name, of course. So I trust these more. Maybe they are not good. Sometimes it happens that the capacitance meter says a good value, but in reality it's not good. For what I need them, if the speaker sounds okay and the value is okay, it's good enough for me. You may remember these two tweeters from previous video. They are car speakers, car tweeters. Now I found a purpose for them. They will be used together. They are 4 ohm each. Of course, this one, because I opened it and fixed it, I think I put the magnet inside, other way around. They started in the first place, they had positive on this end, negative on this end, positive on this, negative on this. But because I turned around the magnet inside, the polarity on this one has changed, and now positive is here, negative is here. So as always, I soldered the caps to the negative. These are One moment, so I check. 4.7 microfarads at 50 volts. Same for both of them because they are both 4 ohms. And let me check with the table. The table actually did not go that far, but had an online calculator lower in this page, so I calculated with that. They will, of course, the value of two 4.7 microfarads in series is 2.35, and they will start to produce sound at about 17,000 hertz, so they will be used as some kind of super tweeters. I'm not really sure if these car tweeters are meant to produce this higher frequency sound. I will test them, and if they produce it okay, I will leave them like this with these caps. If they don't produce any sound, then I will change the caps to lower their working frequency a little bit, but I think they should be okay, because from what I found online, from old magazines that were scanned by somebody, even these speakers go to 17,000 hertz. So these that are actually tweeters should go beyond that with no problems. So this is the basics. Of course, because I use them in the same enclosure with that big speaker, the air moving from it will move their membrane very much and will destroy them, would destroy them. So I will make them closed. Like, one moment, I have a closed speaker here. Okay, this is a closed speaker that can be used with a woofer and an enclosure. So I will close them with cardboard, just glued all around. I've done this before and it worked really well, no problems. So I will do it again, and we will see how everything goes in the end. But I don't see any reason for it not to work. So let's give these speakers a quick test, so you can see how they sound. Of course, this test will be unfiltered. The negative. And positive. Of course, when testing just one speaker, this doesn't really matter, because if it when it produces sound, if it first comes out and then back in, it makes absolutely no difference for us. But when they are two in pair, if one comes out and the other goes in, they actually cancel each other, and the sound does not come from the center of the two speakers. You hear it like it's, I don't know, distorted somewhere in the background. I will make a video of that with one of my sound system, and maybe you can hear the difference. But be careful with this, because I found good speakers, factory made, which had wires in them soldered the wrong way around. So it sometimes happens even in factory made speakers, and that's really bad, because you pay a lot of money maybe on them and you wonder why they sound so bad, and you end up giving them away, selling them, throwing them, when it actually is just a wrong wire. But it sometimes happens. So let's test this. I need to power up everything around here. Let me put it on a low volume. the bass remained a little bit high from the testing of the Visaton 15-inch speaker. Now I fixed that. A little bit of the image showing my hair. Sorry for that. I will not be testing all of them, only one of each kind, because I already tested them and I know they work well. I cannot test them directly to the capacitors because that would be bad for the amplifier. It would actually see no impedance, so that's not good. Okay. You maybe hear a little bit more highs. Okay. Did the melody end, or one of my connections isn't good? Let me check. Yeah, the melody ended. And I don't seem to have any more internet connection, so I will have to stop the video for a moment until I connect to internet again and can play music again. Back online. Internet problem solved. As you hear, this goes pretty high. I really like this speaker for what I'm going to use it. If you hear any rattling, it's because of the alligator clips. They are cheap Chinese made ones. They don't hold very well, but this is what I've got. Okay, power down. Never change this with power on, because if you make a short you will kill the power amplifier. Sorry for all the time, I don't know why I'm doing this. I'm trying not to do it, but I sometimes forget. Okay, trying to figure out how to put this alligator clip on without blowing up stuff. This should be okay, but I will keep it in my hand. So let's see how this works. Maybe you hear my wife in the background, sorry for that. Okay, this seems to be a lot higher frequency than what the other speakers can do, so this will probably work for as super tweeters, I hope. We will not keep this for a very long time, because of course we are putting unfiltered sound to a tweeter. Its coil will heat up a lot quicker than a normal speaker coil. And let's test even the one that was completely blocked when I got it, to see how it does after about a week or so from fixing. I hope it's okay. Okay. Of course the melody has changed. I will try to put back the other one, so we will have something to compare it to. Okay, it sounds good. Great. I'm happy with them. I think one of the speakers I did not test in this video. I have no idea which one of them. I think one of these two, but they are the same, so it doesn't really matter. Okay, so caps on, soldered. I will glue the... okay, I can't remember the word now. The paper, but thicker paper. Cardboard, okay, I remembered. The cardboard around here. Put some foam around this, so the enclosure will be a sealed one. Of course I will do that to all the speakers. For these two I will drill some holes, put some silicone around them and put them into the holes until they stay flat with the surface. So we will see how everything goes, and if anything doesn't sound well, of course I will change my design, caps, values, even speakers if needed. We will see. So thank you for watching. See you again next time. Bye. Back with a fail on my part. I did not change the polarity on this tweeter when I fixed it by what I thought was putting the magnet the other way around. I actually just tested wrong this one. Maybe I hold it like this or like this, and then when I wrote on it I don't know, I did something, so I wrote plus on this and minus on this, and it actually is completely opposite. So you can see now, one moment, I hope you can see, it's going outwards, so This is clearly positive, exactly like this one, positive. Let me show you. Okay, my fingers are on the invalid. It moves just a little bit, but I think it's enough. So you can see, I hope, goes outwards. So this one, back to the drawing board, move the caps here and change the markings on the tweeter. So it's always good to double check anything that you do. This would have sounded bad, and I wouldn't know why. So always double check. Thanks for watching, and this time I hope for goodbye for this video.